Okay, we're going to continue with 8.1, and in 8.1 we talked about the different sets of real numbers, and now we are going to compare real numbers. All right, in number 1 it says -2 equals +2. Is that true or false? That would be false. All right, number 2 says 0 is less than or equal to 5. Now this symbol means less than or equal to. So it doesn't mean that it has to be both. So if either one of those two are true, then it's a true statement. So is 0 less than 5 or equal to 5? Since it's less than 5, then that would be true. Okay, for number 3, -3 is greater than -1. Well, if you're not sure about that, you can always think about the number line. Okay, so if we think back to the number line, we would have 0, -1, -2, -3, and so on. So if we have the positive numbers, we know that the positive numbers get bigger as we go to the right. Well, it's the same thing all the way across the number line. So even though these numbers look bigger, since they're to the left, they're smaller. So anything to the left is smaller, anything to the right is bigger. So since -3 is to the left of -1, that means -3 is less than -1. So this would be a false statement because it says -3 is greater than -1. All right, for number 4, we have the absolute value of 6 equals -6. Well, first, let's talk about what absolute value means. Absolute value means it's asking how far is the number from 0 on the number line. So how far is 6 from 0 on the number line? It's 6 spaces. Absolute value can never be negative because it's a distance. It's how far a number is from 0 on the number line. So the absolute value of 6 is 6. Does that equal -6? No. So that would be false. Number 5, we have the square root of 16 equals 4. Well, anytime we have something that can be simplified, we need to simplify it before we compare it. What is the square root of 16? The square root of 16 is 4. So this is really 4 equals 4. Is that true? Yes, that's true. Okay, for number 6, we have 3.14 equals pi. Is that true or false? This one's a little bit tricky. Remember when we defined pi, what kind of number did we say it was? We said that it was an irrational number. And remember, an irrational number doesn't stop and it doesn't repeat. Well, the way this is written, this stops, 3.14. If it were written like this, 3.14, and then we had these dots, the ellipses, that says that it keeps going. It doesn't stop. Well, this doesn't have that. So the way that it's written, this is false. If it were written like this, that would be true. Okay, so now let's, it says to fill in the blank with the correct symbol. Okay, so if we look at A, we're comparing two fractions. But the problem is the fractions don't have the same denominator. And in order to compare two fractions, we have to have the same denominator. So we need to get a common denominator first. The least common denominator between 5 and 11 would be 55. So I need to multiply this first fraction to get this 5 to be 55. I would have to multiply times 11. Well, anytime we multiply one part of a fraction times a number, we have to do the same thing to the other part of the fraction. So this would give me 44 over 55. Okay, and then to get 11 to be 55, we're going to multiply times 5. So since I'm multiplying the denominator times 5, I need to multiply the numerator times 5. And that would give me 45 over 55. So now that the denominators are the same, I can just compare the numerators. And we know that 44 is less than 45. In B, we have decimals. And when we compare decimals, we need to have the same number of decimal places. So in this first decimal, we go to the thousandths place. So we need to do the same thing in the second term. So in order to do that, I'm just going to add a 0. So now since the first several decimals are the same, we really only have to compare the last decimal. So we know that 1 is greater than 0. So we would write it like this. Or you could think of it as 21 is greater than 20. However you want to compare that. All right, in C we have a fraction and we have a decimal. So we either need them both to be the same fractions with the same denominators, or we need to have the same, we need to have them both as decimals to the same number of decimal places. Okay, so if we want to change this decimal into a fraction, first let's say what this decimal is. What is this decimal? Well, this decimal is 4/10. So the way that we could write this, we could also write 4/10 as 4/10. And that would be, those are equivalent. So now we need to get the two fractions to have the same denominator. All right, so in order to get them to have the same denominator, the least common denominator would be 70. So I'm going to multiply this first fraction times 10, both the numerator and the denominator. So that gives me 20 over 70. And then this fraction I need to multiply times 7. And that would give me 28 over 70. Well, we know, again, since the denominators are now the same, we just multiply the numerators. And I know that 20 is less than 28. Okay, so if I wanted to instead change both terms into decimals, then all I would need to do is rewrite this fraction. In order to rewrite it as a decimal, then I would just divide the numerator by the denominator. Okay, so I would take the 2 and divide it by 7. Well, 7 cannot go into 2. So I just need to add a 0. I'm going to put a decimal and add a 0, so I need to bring that decimal up to the top. So now I have 20. 7 can go into 20 2 times, and that would give me 14. And then if I subtract, I get 6. Okay, so if I add another 0, 7 can go into 6 8 times, and that would give me 56, but I really don't need to go that far. Okay, so I have 0.28, and I'm going to compare that to the 0.40, and 28 is less than 40, so we got the same answer whether we changed it to a decimal or to a fraction, and you can choose which method you prefer. And that's how we compare real numbers.